1:47 a.m. Eastern. Let's take a quick look at that launch.
Engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis I. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis I. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour. You're looking at 8.8 million pounds of maximum thrust. Quiet here.
And there you did see a replay of that launch of the Space Launch System, which blasted off from the Kennedy Space Center at 12:47 a.m. Central. Now, following liftoff, those solar arrays were deployed, and we had trans-lunar injection, which took place, and the ICPS separation also occurred. Now, just a short time ago, Orion conducted the first trajectory adjustment burn and completed a checkout of the orbital maneuvering system, or OMS engine, and all went smoothly during that 30-second burn. Orion is continuing its journey to the moon, and we are anticipating views shortly as part of an Imagery event. Now, as you can see on your screen, Orion is over 55,500 miles away from Earth, now 9 hours into its flight, but still 204,000 miles away from the moon. Of course, that distance will get less and less over the next few days, and at closest approach, Orion will be about 60 nautical miles above the surface of the moon. And we are starting to get some of our very first views of the Orion spacecraft. Great view right there in the center of your screen of that large engine, the orbital maneuvering system, or OMS engine, which just performed that orbital trajectory correction maneuver. Again, that all went smoothly. That OMS engine is the main engine and is a repurposed Space Shuttle Orbital Maneuvering System engine that has flown in space 19 times during Space Shuttle flights ranging from 1984 to 2002. And on the side of the Orion spacecraft, you also see some of the auxiliary engines on Orion. There's 8 of those auxiliary engines located on the bottom of the European service module in 4 sets of 2. These are fixed at the bottom to provide trajectory corrections and as a backup to that main engine, the OMS engine. Each of those auxiliary engines provide about 100 pounds of thrust. And there are also 24 smaller engines grouped into 6 pods on Orion, which provide attitude control. They can be fired individually as needed to move the spacecraft in different directions and rotate it into any position. So in total, the service module has We are now over 9 hours into the flight of Artemis I. Again, SLS launched from the Kennedy Space Center in Florida at 12:47 a.m. Central Time, 1:47 a.m. Eastern. Orion will be completing a 25-day mission as part of Artemis I with a splashdown slated for December 11th. Continuing to get some views of the Orbital Maneuvering System, or OMS engine, as well as those auxiliary engines. So as we continue to anticipate some additional views during this imagery event, these views will be gathered on cameras that Orion is equipped with. There's actually 3 different groups that fly on the vehicle itself. These include some internal cabin cameras that are, of course, inside Orion. And Orion is an uncrewed test flight, but when we do fly humans on board soon, these cameras will be capturing views of the crew inside Orion. And even though there isn't a crew inside Orion for this mission, we do have those internal cameras still on board to test out their capabilities. And there are also external cameras, and those cameras are mainly used for flight test objectives, or FTOs, in critical mission phases to check out how the vehicle is operating and performing. And then there's what we call external SAW cameras. The SAW camera is a solar array wing camera. Basically, the solar array wings are those X-shaped wings that stick out on the bottom of the Orion vehicle. We aren't getting imagery of that just yet, but we might hear shortly. These are used to collect solar power and distribute that to the vehicle itself. And then on the very edge of the solar array wings, there are the cameras, which are used to view different angles of the capsule itself. The SAW cameras can be rotated to get a different view and perspective from the camera. And on this graphic that you're seeing here on your screen, you can make out slightly the solar arrays, those black X-shaped figures there. And that is where those SAW cameras are located that we were just discussing. Orion is over 56,000 miles away from Earth, but still has about 204,000 miles in its journey to the moon. Again, this is a test flight of the Orion vehicle and its capabilities, resulting in a 25-day mission with splashdown on December 11th. The team here in Mission Control Houston continues to support, and here shortly the team will ensure that the SAW or solar array wing cameras are positioned correctly as we anticipate imagery here a short while from now. Now, this view of potentially Earth will be a little different than what we're used to seeing from the International Space Station, which orbits about 250 miles above Earth. Now, as just mentioned, Orion is currently over 50,000 miles away, so should be a pretty breathtaking image. Now, of course, throughout the coming days, we will expect to see the Earth grow smaller and smaller and the Moon grow larger in the field of view as Orion approaches its destination. As Orion continues its journey towards the Moon, now over 9 hours since it launched from the Kennedy Space Center in Florida, let's look at a broad overview of the Artemis mission to see what has happened so far and what is still to come.
Welcome to the moon board. We got this just in time for the first mission in Artemis, Artemis I, so let me use it now to take you through. As always, we're going to start off with a launch. In this case, 4 RS-25 engines ignite, 2 solid rocket boosters sending SLS and Orion skyward. On the way uphill, a couple of jettison events, things coming off of the rocket. One of the most visual will be these 2 solid rocket boosters coming off about 2 minutes into the flight after all of their propellant's gone. We also have 3 fairings protecting Orion on the way uphill, as well as the launch abort system that will come off. Now, after we get through all of the propellant in that giant core stage, we'll hear MECO, main engine cutoff. It will drop away, turning propulsion over to this, the interim cryogenic propulsion stage, or ICPS. It's going to make its first maneuver to raise up the lowest part of our orbit around Earth, really put us in a nice circular path around our planet. And while we're in Earth orbit, we can check out Orion, make sure its systems are functioning as we expect before we commit to sending it to the Moon. That happens here, the trans-lunar injection, to a 20-minute firing of this ICPS upper stage. And what that's designed to do is really give Orion enough energy to get out of low Earth orbit and make its way to the Moon. Shortly after that, the ICPS will separate. Its job pushing Orion is done. It has a couple of secondary payloads in here, some CubeSats that it'll deploy, ultimately sending itself on a path around the Moon before it escapes and goes into orbit around the Sun. Meanwhile, Orion, though, continues on its journey. It'll make some correction burns as it fine-tunes its path towards our lunar neighbor before we get into all the exciting stuff up close. We'll dip in for a 60 nautical mile flyby of the lunar surface using the engines on the European Service Module to push us around and into distant retrograde orbit, or DRO. That's this dotted line that you can see up here. This is really where we're going to learn about about Orion while we fly around the moon, about 38,000 miles off the lunar surface. And we call it retrograde as the moon is heading in that direction. Orion will be heading in this one, opposite retrograde. Now, after we're done in that orbit, it'll be time to come home. We'll execute a maneuver to exit, do another flyby close to the lunar surface that commits us to coming home and fine-tuning our path towards the atmosphere. We'll make any correction burns on our way back as necessary before it's time to re-enter the atmosphere. Now, before that can happen, we'll have a spacecraft separation event. The service module, its job is done. It breaks away, ends up burning up in the atmosphere after carrying Orion to the moon and back. What this does is reveal the heat shield, the large structure on the base of Orion. Testing this is our #1 goal for the Artemis I flight, because when we come back from the moon, we're going to be moving at 25,000 miles an hour. That's 8,000 miles an hour faster than when you come home from the International Space Station. And what that's going to cause is this to heat up to about 5,000 degrees Fahrenheit. That's half the temperature if you were standing on the surface of the sun. So things will be very hot, but that heat shield does its job to protect the Orion capsule, which will be bringing our astronauts home at the end of these future missions. After we're through that fiery re-entry, parachutes deploy, Orion splashes down in the ocean. We'll have a U.S. Navy ship standing by with recovery personnel to pick Orion up out of the water and bring it in to the first flight in the Artemis program.
And if you're just tuning in with us, Orion launched from the Kennedy Space Center in Florida at 12:47 a.m. Central, 1:47 a.m. Eastern, and is on its way to the moon. Following translunar injection and the first orbital trajectory correction burn earlier this morning, Orion is now over 50,000 miles away from Earth, and we're beginning to see imagery from Orion, most notably of the large main engine on the European service module, the OMS, or Orbital Maneuvering System engine. We're also getting some views of the smaller auxiliary engines located to the left and the right of the OMS engine. There are 8 auxiliary engines in all on board Orion. Now again, that main engine that you're seeing, the largest engine, the Orbital Maneuvering System engine, was used just a short time ago to perform a burn that lasted about 30 seconds. All went smoothly during that burn. The engine can provide 6,000 pounds of thrust and is equipped to steer the spacecraft, and can also be used in some abort cases to safely return Orion to Earth. This engine that you see in the center, the module there, flew on 19 space shuttle flights, beginning with STS-41G in October of 1984 and ending with STS-112 in October of 2002. As Orion continues its journey to the moon, we do anticipate potential Earth views here in a short time. At this hour, now 9 hours and 19 minutes since launch, Orion is 57,000 miles away from Earth, closing in on the moon, 203,000 miles away. In this animation, you can see the SAW or solar array wings as they are being oriented in anticipation of this imagery event. So again, that SAW camera is a solar array wing camera. The solar arrays are that X-shaped wing that sticks out of the bottom of Orion that you can see on your screen there. They're used to collect solar power and distribute that to the vehicle itself. And on the very end of these wings are cameras which can capture different views of the capsule itself. Those wings can be rotated to gather different angles and viewpoints. The team here in Mission Control Houston is continuing to ensure that the solar arrays are positioned correctly for the upcoming imagery event. And again, in this shot, we're now seeing a slightly different angle of those auxiliary engines on the sides of the orbital maneuvering system engine. That's that larger engine right in the middle of the European service module. And we are actually seeing a little bit of movement in the solar array wings 2 and 3 in anticipation of the imagery event. Continuing to get a different perspective of Orion and the European service module as those solar array wings continue to move. As with nearly everything else during Artemis I, the two main objectives for the imagery system is to capture the flight test objective data and ensure we have a safe built vehicle for crew to fly on. Really starting to be able to make out that solar array wing now in the bottom left, now more middle of your screen. And you're seeing there on your screen our first Earth views. This view of Earth captured from a human-rated spacecraft not seen since 1972 during the final Apollo mission some 50 years ago. The views of our blue marble in the blackness of space now capturing the imagination of a new generation, the Artemis generation. Orion looking back at Earth as it travels toward the moon 57,000 miles away from the place we call home. And as we continue to marvel in this spectacular image here in Mission Control Houston, you have a great view of the Orbital Maneuvering System, or OMS engine, that main engine on the top left of your screen there that was used an hour and 43 minutes ago to perform the OTC, or outbound trajectory correction maneuver, as well as a few of the auxiliary engines on the bottom of the European service module, flanked by the solar array wing on the right portion, right above the Earth on your screen. And here are some statistics on Orion, now 57,000 miles away from Earth, nearly 58,000 miles away, and 203,000 miles away from the Moon, traveling at 5,459 miles per hour. If you're just tuning in with us, you're looking at a breathtaking live view of the Earth from the Orion spacecraft as it makes its journey to the moon. Orion launched earlier today at 12:47 a.m. Central, 1:47 a.m. Eastern, atop the Space Launch System, and is in hour 9.5 of its 25-day test flight mission. We are continuing to get these views of Earth from the Solar Array Wing camera. The solar array wing can be seen there in the center of your screen, that rectangular shaped object. Orion is now over 58,000 miles away from Earth. And you can see there the X-shaped figures on your screen. Those are the solar array wings themselves, which were where the camera views we were getting were from. And this view from inside the Orion vehicle. This is a uncrewed test flight, but on the left of your screen there, we do have one of our purposeful passengers, our Moonikin, who is wearing the Orion Crew Survival Spacesuit. This will be the spacesuit that will be utilized by astronauts when they launch to the moon on Artemis II. On the right of your screen there, you can see one of the windows that our crew members will have the opportunity to look out from once they make their journey to the moon. Again, if you're just joining us, you're looking at an in-cabin view of the uncrewed Orion vehicle. On the left of the screen, there is one of our purposeful passengers wearing the Orion crew survival suit that will be utilized and worn by astronauts during the dynamic phases of flight to the moon. As this is a test mission, while all of the components of Orion and the Space Launch System are being tested, the Orion crew survival suit is now having the opportunity to be tested in space as well. We're continuing to get in-cabin views inside the Orion spacecraft. Orion lifted off from the Kennedy Space Center in Florida 9.5 hours ago as part of a 25-day test flight around the moon and into deep space. Orion is slated to splash down on December 11th. Again, this is a uncrewed test flight, but we do have our Moonikin pictured there on the left of your screen in the seat. They're wearing the Orion crew survival suit. This is the spacesuit that will be worn by our crew members when they fly inside Orion during dynamic phases of flight. As you can see there, the suit itself is that bright orange color. That is to help make crew members more easily visible in the ocean should they ever need to exit Orion without the assistance of recovery personnel. The spacesuit is also fire resistant and is a pressure garment that includes a restraint layer to control the shape and to ease astronauts' movement while suited up. The suit also has a thermal management system to help keep astronauts cool and dry, and a liquid cooling garment that's worn underneath the suit. The Orion suits will be custom fitted for each crew member to accommodate astronauts of all sizes. And the gloves will be touchscreen compatible to work alongside the systems inside Orion. The Orion crew survival suit is primarily designed for launch and re-entry, but can also keep astronauts safe if Orion were to lose cabin pressure during the journey to the moon. Astronauts could survive inside this spacesuit for up to 6 days as they make their way back to Earth if necessary. And the suits are also equipped with a suite of survival gear in the event that, again, they have to exit Orion after a splashdown. And as we've mentioned, Artemis I is an uncrewed test flight of the Space Launch System and the Orion vehicle. So the Moonikin you see on the left of your screen there does not have a human inside of it, but it does actually have a name. The Moonikin's name is Campos and is dedicated to Arturo Campos, who was a key player in bringing Apollo 13 safely back to Earth. The Moonikin received its name as the result of a competitive bracket contest honoring some of NASA's key figures, programs, and astronomical objects. NASA received more than 300,000 votes, and the winner was Arturo Campos. And with the first live imagery views of Earth from Orion, that will wrap up our coverage for today, but we'll continue to post daily updates about the mission on the Artemis blog at blogs.nasa.gov/Artemis, and we'll also be posting updates on our social media accounts. We'll be back on the air on Monday to cover the outbound powered flyby burn, at which point we will witness Orion's closest approach to the moon, which will be approximately 80 nautical miles. Our coverage will begin at 6:15 a.m. Central, 7:15 a.m. Eastern, with a burn targeted at 6:43 a.m. Central, 7:43 a.m. Eastern, and closest approach occurring at 6:57 a.m. Central, 7:57 a.m. Eastern. Again, when we're not live, you can check out the blog for updates and also subscribe to the NASA newsletter for updates on the spacecraft and mission. And we're also excited to introduce Artemis All Access, which is a short video product released 2 to 3 times weekly that will provide updates about mission accomplishments with a look at what's to come. Plus, we'll have inside looks and explainers. But for now, with Orion continuing its journey to our nearest celestial neighbor, the moon, that will wrap up our coverage for today. Thanks so much for watching us. This is Mission Control Houston.